Good morning. So today we are going to finish up 10.7, which was factoring special cases. So today we're going to talk about the GCF a lot. So that's sort of your first idea, is to factor out GCF if there is one. So what that means is if you have something like 4x squared plus 8x plus 4, you could jump right into your ABC vertically. You could say, okay, that's a perfect square and that's a perfect square. But if you don't factor out the GCF, you're not going to get the full correct answer. So what it means to, so your GCF in this case would be 4, because as much as they all go into 2, 4 is the greatest thing they have in common. And remember, when you're factoring, that basically just means you're dividing. So you're saying divide by 4, divide by 4, divide by 4. The 4 has to stay out. That has to be there for your final answer. And then you're left with x squared plus 2x plus 1, once you take the 4 out of all of those terms. Now, you'll notice this is a perfect square trinomial. And now you're left with x plus 1 squared, where before you had 2 and 2. So this makes it the most simplest form. So when you're factoring out a GCF, it can get a little complicated. So the following examples are going to look similar to a difference of squares, but they're not, because as much as they have 2 terms, right, the A and the C, so they have 2 terms, they're not perfect squares. Okay, so because they're not perfect squares, you can't x plus a number, x minus a number these. However, you can see that they do have a perfect square maybe lying in there. So again, factor out the GCF if there is one. So if it looks like something you should be able to factor, ask yourself, is there a GCF I can factor out? And the answer to that is yes. They both have a 2 in them because they're even numbers. So 98 divided by 2 is 49, and 50 divided by 2 is 25. Now I can factor using difference of squares. Because that is a perfect square, and that is a perfect square. Remember, the 2 has to stay. So it becomes 2, 7x minus 5, 7x plus 5. Not too bad. So the same goes with B. This looks like it would be a difference of squares. Again, no B term, 2 terms. However, there's something that can be factored out of both of these. So think, what number goes into both 27 and 12? It's 3, leaving you with 9x squared minus 4. If you factor out a GCF and you don't get 2 perfect squares, think if there's a number that you're missing, or make sure that you didn't mess up when you divided. So now we know that the square root of 9 is 3, square root of 4 is 2, so it is 3, 3x minus 2, 3x plus 2. So let's try another one. We have 8x squared minus 1. So again, looks like it should be difference of squares. Now ask yourself, can I factor something out of this? And the answer is no, because that's a 1. Can't factor anything out of a 1 other than 1. And 8's not a perfect square. So it is not factorable. And there's going to be cases where they're not factorable. 8 is not a perfect square. Also, in the same breath, if you had something like 16x squared plus 4, 16x squared plus 4, also not factorable. Not a difference. You cannot have a plus sign connecting these two because if you had opposite signs, it wouldn't work. So there are cases where they're not going to be factorable. One is if they're not perfect squares. One is if they're plus sign. All right, let's look at one more here. We have 12x squared plus 12x plus 3. So again, looks like it could fit under the bill of a vertical ABC. Maybe might fit under perfect square. Not right now though, because 12's not and 3's not. But let's see what we can do. So what number is the greatest number that goes into all three? The number 3. Leaving you with 4x squared plus 4x plus 1. And that tells you here, perfect square, 3 times 2x plus 1 squared. Now again, if you don't see this pattern and you ABC it, that's perfectly fine. Just know that this is how it should be written or could be written if it was a multiple choice. All right, that is the rest of 10.7. Good luck.